In this video, we're going to learn how to graph the tangent and cotangent functions using transformations. So we're going to start with y is equal to 2 tangent of x minus 1. Now we're going to start by graphing this function, and then we'll use that graph to determine its domain and range. But before we get started, let's go over what the key points of tangent of x are. At tangent of 0, it is 0. Tangent of pi over 4, it's 1. At tangent of pi over 2, it is undefined, which is going to cause that vertical asymptote for us. And at 3 pi over 4, it's negative 1. Then pi, it's 0, and it'll start to repeat its cycle. And we learned in previous lessons that the period of tangent and cotangent is pi. So when I go to calculate its period, I won't use 2 pi over b. I'll just use pi over b. But you'll see here that b is 1, or an understood 1 in front of that x. So my period remains the same. It's just pi. So for the rest of these points, I'm not going to alter the x value of my key points. What's going to instead happen is that I'm going to alter my y value with that 2 and that minus 1. And we'll start with multiplying by 2 first, just to do our order of operations. I mean, don't go out of sequence. So we'll have y is equal to 2 tangent of x, which means we multiply our y values by 2. So 0 times 2 is 0. 1 times 2 is 2. Undefined times 2, that's just going to remain undefined. Negative 1 times 2 is negative 2. 0 times 2 is 0. Now we'll subtract 1. So 0 minus 1 is negative 1. 2 minus 1 is 1. Undefined minus 1, again, remains undefined. Negative 2 minus 1 is negative 3. And 0 minus 1 is negative 1. And now we'll go ahead and plot these points. So 0, negative 1. Pi over 4, 1. Then at pi over 2, it's undefined, so I'm going to put a vertical asymptote. Then at 3 pi over 4, it's negative 3. Then at pi, it's negative 1. And then it repeats this process. So again, the next point after pi, next pi over 4 over, would be 1. And then I would have my asymptote. And then after the asymptote, it should be negative 3, then negative 1, then 1, then an asymptote. Negative 3, negative 1, and I can also do the opposite direction. After my negative 1 point, going backwards would be negative 3. After the negative 3 would be my asymptote. And again, keeping up that pattern. Now again, be very careful. Sometimes people go backwards. They'll go up to 1 because they would see that point just across from it, but this is not an even function, so that wouldn't happen. So again, following it backwards, after the asymptote would be 1, then negative 1, then negative 3, and I'll stop it there. That's enough points for me to use. And again, that tangent function has a sort of swerve to it at the middle point. So as I follow my asymptote, I'll go through. I kind of bend a little bit at the middle point, and then I'll curve and go and follow my asymptote. And I'll do that every time. And that would be the graph of 2 tangent of x minus 1. And it would continue forever in both directions. And just so we have a nice visual, I'll continue the pattern to the left so you can see it over here as well. Now, the domain for this function has a lot of gaps in it. And it seems to happen at pi over 2, 3 pi over 2, 5 pi over 2, negative 1 pi over 2, negative 3, but always an odd number by that pi at the top. So what I'll say for my domain is that it's every x such that x does not equal some k pi over 2, where that k is an odd number, or an odd integer to be more specific. And this is set notation for doing domain and range. It just lets me know that I can use any x I want to, just not these particular ones. Now the range for this, you'll see here, it goes, it follows these asymptotes as far as down as they go and as far as up as they go. So the range is just going to be negative infinity to positive infinity. It'll hit every y value possible. Now next we're going to look at y is equal to 3 cotangent of negative 2x. Now to start this problem off, I have a negative inside my trig function, and I know how to take care of those now. So y should equal negative 3 cotangent of 2x. That negative just comes on the outside since cotangent is an odd function. Now let's look at its period, which would be pi over b, which in this case, b is 2, so the period is pi over 2. So my function will go from 0 to pi over 2 this time. And now I have to evenly distribute those x values in between. So we'll start by looking at y is equal to cotangent of 2x. In order to get all these points in the middle here, what do I need to count by? I can just divide pi over 2 by 4, or multiply by 1/4, and I'll see it happens every pi over 8. So 0 plus pi over 8 is pi over 8. Pi over 8 plus pi over 8 would be 2 pi over 8, also known as pi over 4 when you simplify. 2 pi over 8 plus pi over 8 is 3 pi over 8. And 3 pi over 8 plus pi over 8 is 4 pi over 8, which is pi over 2. Again, we're not going to adjust our y values yet, but I actually haven't labeled them yet because I haven't gone over my key points for cotangent, which cotangent of 0 is undefined. Cotangent of pi over 4 is 1. Cotangent of pi over 2 is 0. Cotangent of 3 pi over 4 is -1. And the cotangent of pi is undefined. So a little bit different from tangent in the fact that it's descending in values. And then its asymptotes are at 0 and pi instead of pi over 2. But again, these are not going to be affected by our period change. But now let's look at what happens when we apply this -3 that's out in front of cotangents. Again, we've already taken care of the period. So we know what's happening to our x values, but now we're going to figure out what's going to happen to these y values. So undefined times -3 still remains undefined. 1 times -3 is -3. 0 times -3 is 0. -1 times -3 is 3. And undefined times -3 is undefined. And now we'll go ahead and graph. So at 0, it's undefined, so we'll have an asymptote. Then at pi over 8, which is in between 0 and pi over 4, it's -3. Then at 0, at pi over 4, 3 at 3 pi over 8, then at pi over 2, it has our asymptote again. Again, continuing the same pattern, after the asymptote, it's -3, then 0, then 3, then the asymptote again. And then -3, 0, then 3, and then an asymptote at this very edge of my graph paper. And going backwards, after the asymptote would be 3, then 0, then -3, then an asymptote. And I can continue this pattern for the length of my graph paper. It doesn't take too long to do. And another asymptote at the very edge of my graph paper again. Now I'll go to graph this, and it makes a similar shape as tangent. And now this negative out in front kind of flipped it upside down. So normally cotangent would be going downwards, but since I use a -3, now it looks like it's going upwards. So again, I'll follow my points. This one's a little bit steeper, so the little swerve in the middle is a little less noticeable. And now we can find our domain. So our domain now, our asymptotes are every pi over 2. So again, when I make my domain, I can use any x value I want such that x does not equal any multiple of pi over 2. So I'll just put k pi over 2, where k is an integer, which includes 0 as well. 0 pi over 2 would be 0, then 1 pi over 2, 2 pi over 2, 3 pi over 2, and so on. And every one of those are out of the domain. And again, the range is going to be all real numbers, negative infinity to positive infinity. And that is how you graph the tangent and cotangent functions using transformations.